Okay, guys, so we're looking in our notes packet at notes part 5. Shh. We are talking about something called the law of signs. It's not S-I-G-N-S, it's S-I-N-E-S, which means ratios, that sign ratio. The law of signs can be used to find side and angle measures if we're given two angles on any side, or if we're given two side lengths and an angle outside of them. So if we're given angle, angle, side, or angle, side, angle, we can find the missing side. If we're giving sine, side, angle, then we can find the other missing angle. So our whole goal is to be able to find all the angles and all the sides of triangles. So what the law of signs says is this, that we can do the sine of A equal to, over side A is equal to the sine of angle B over the side B, and also equal to the sine of angle C over side C. The reciprocals would also be true. Like I could do A over sine A equals B over sine B. When I have these three sets, it just means I can use any two at a time. I can use these two, I can use these two, or I can use the first and the third, whatever's the most helpful. All right, so let's look at this first problem. Find each missing measure. Round all answers to the nearest tenth. Okay, so I'm going to call this A, this B, and this C. So based on this rule, I'm going to look at this angle. I can do the sine of that angle's 52, over. Now, the way this works is if this is angle A, this is called side A because it's right across from it. So this is my side A. So I do my sine of my angle A over my side A, which is X. That's equal to, now I can use either one, B or C. I put C here, I'm going to use C. So it's going to be the sine of 34 degrees over the side across from that, because this would be my side C, and that's going to be 10. So now I cross multiply. I get X times the sine of 34 degrees equals 10 times the sine of 52 degrees. I have to divide by the sine of 34 degrees. So this right here would solve for X, would solve for side A. So typing that in, making sure my calculator's in degrees, you guys don't have to check that. 10 times the sine of 52 divided by the sine of 34. Did everyone get 14.01 or 14.1 to the nearest 10? Okay, should I make that in degrees, minutes, and seconds? No, it's the length of a side. Don't want to do that. All right, so now you guys can label this however you want, and then I want somebody to raise their hand and tell me how they set it up. Can anybody just tell me the setup? What's it going to be, Cooper?
The sine of 119 over x equals the sine of 21 over 7.
Okay, now, I'd like you to be able to do this pretty quickly. Could you understand how this would end up being? X would be equal to 7 times the sine of 119 divided by the sine of 21. Can you think ahead and do that? If you can't, you can write it all out, but I'd love for you to be able to just go directly to that. And you should get 17.1. Okay, questions? It's not so bad, right? Okay, what about on something like this? Okay, I start to set this up. I would do the sine of 64 over 32. But watch, if I want to find this, I can't use the sine of 45 degrees. What am I going to have to find? The other angle. And how do I find it? Right, so I'm just going to do 180 minus 64 and minus 45. And it's 71 degrees. So now I could do the problem. Sine of 64 over 32 equals the sine of 71 over x. And doing it all in one step, it would be x equals 32 times the sine of 71 degrees divided by the sine of 64 degrees. And we get 33.7, and that's an approximation, so we use the squiggles. All right, same thing here, we'd have to find that angle. We're not going to do that one, it's just like number 3. Let's go down here to number 5. Kevin, Adam, and Dan are passing a hockey puck. How far is Kevin from Adam, based on this information? So we want to find this, Kevin to Adam. Want to find that. Do we need to find anything else out first in order to be able to find that? What do we need? That third angle, don't we? So I can do that by doing 180 minus 71 and minus 86, 23. And now we could set it up. Sine of 23 over x equals the sine of 86 over 25. And maybe you can do it without writing anything now. It's fine to try that, just be really careful. It would end up being divided by that one, wouldn't it? So it's 9.8. And if you find yourself making mistakes when you do those shortcuts, then don't do them, okay? You don't have to. I'm just showing you how you can. All right, let's go over to the back now. Now we're going to be switching gears a little bit here, because now we're going to be finding angles if we're given two sides in an angle. Now, we have to be careful, though. When we're finding angles, it's possible to have one solution, two solutions, or no solution. This is called the ambiguous case because we don't know. Ambiguous means it's not clear. So it could be one of these situations. The sine function always has a range between what and what. Well, here's the sine values we can get. On that unit circle, this point right here is 0, negative 1. This point right here is 1, 0. This point right here is 0, 1. And this point right here is negative 1, 0. Remember how y is our sine ratio? So negative 1 is the smallest value we can get, and positive 1 is the largest. Right here, our y value would be 1/2. Here it's radical 2 over 2. Here it's radical 3 over 2. All of those are less than 1. So this should be between negative 1 and 1. If we get something that is not between negative 1 and 1, let me show you this. If I use my calculator and I do second sine of 1, it'll give me an answer. What is that? 90 what? Degrees. I can do second sine of negative 1, negative 90 degrees. Second sine of 0, right there, this should tell me 0, it does. But watch if I do second sine of 1.52. Tells me that there's no answer, right? Because there is no sine ratio that's going to be larger than 1 or less than negative 1. If the sine function is positive, then the angle can lie in either quadrant 1 or what else? Which quadrants has sine ratios positive? 1 and 2. To find the other possible angle, what would we do? Subtract from what? 180. The sum of the angle measures in a triangle is always 180. No triangle can have two of what types of angles? Obtuse, correct? And something else too. Right. Okay? Can't happen. Let's draw a picture. We're going to start off with an easy one. It's best to draw pictures on these. Just go A, B, C, however you want to go. A is 50 degrees. AB, side AB's here, is 4. BC, this side here is 9. It's asking us to find angle C, so I'm going to call this X. So when I solve this, I would do the sine of 50 over 9 equals the sine of X over 4. I cross multiply. I'm going to get 9 sine X equals 4 sine of 50. I divide by 9. So now I want to do this right here first. So in my calculator, I'm going to do 4 sine of 50 divided by 9, and it gives me this. If I'm looking for an angle, what do I have to push now? Yeah, I have to do sine to the -1, or inverse sine. So I have to do second sine of that answer. To get that answer without typing it in again, I can just push that right there. See how it says answer? So I do second negative, and it'll do the inverse of the previous answer, and it's 19.9 degrees. What's it tell me to raise? Doesn't tell me. Let's go to the nearest 10th. So X then is going to be 19.9 degrees. But is there another angle I could use? Well, in the second quadrant, I would also get this ratio, so I should do what's 180 minus this. And I get 160.1. Why is it that that could not be an answer, though? That's already 50 degrees, isn't it? If I had an angle of 160, that's going to be too much to make a triangle, right? But I do have to check that every time, which is a bit of a pain. But that's going to be my angle. Has to be. Plus, think about this, guys. If this is 50 degrees and that's 9, and this is only 4, what has to be true of this angle? It has to be smaller, right? And it's not, if I got that 160. Okay, so now let's look at this one. B's 37 degrees, AB's 47, AC is 29, find angle C. All right, so we're going to set it up again. We've got sine of 37 over 29 equals sine X over 47. Now, what do we know this time about angle X? It's going to have to be what? Has to be larger than 37, doesn't it? See, think about it. If I have a small angle, across from that small angle is going to be a small side right there. But if I have a big angle, it has to be a large side across from it. Okay, so I cross multiply. I'm going to get sine X equals 47 sine of 37 over 29. Okay, so I'm going to do 47 sine 37 divided by 29. I'm going to look at that answer. Second sine of that last answer is this. So X is going to be 77.3 degrees. I check. Does it make sense? Yep, it had to be bigger. Could it be 180 minus 77.3? Because I could also have that ratio. Would it be okay for it to be 102.7? It would, wouldn't it? Because that's not going to make it too many degrees. So now I have to say X is either this or X could be 102.7. We have to get two answers there. All right, let's look at this one. Okay, so this time C is 75, AB is 28, AC is 19. Find angle B. All right, so we set it up. Sine X over 19. So we're going to cross multiply. Can you think ahead and realize that sine X is going to be 19 sine 75 over 28? You guys able to do that in one step like that? Okay. Okay, and I get 40, well, I'll just call that 41 degrees for x. Now I have to check it though. I have to see what about 180 minus that. Well, could I use 139 degrees? Would that make sense? Nope. So just one answer there. All right. We're going to do one more. Call that A, and that's 114. Doesn't matter which order you go or anything. This is 34 and 12. Okay. Right now, I already know that this is no solution. Can anybody explain why? Go ahead, Cooper.
Because 114 is obtuse, and that can only be, there can only be one of those, but it's on the short side, so can't do that.
Yeah. When I look at this angle is the largest one. This has to be the largest side. That side's larger. So I already know it's no solution. But let's look at how will it look mathematically. So I set this up. I go sine of 114 over 12, sine x over 34. So I'd cross multiply. I would get sine x equals 34 sine 114 over 12. So watch what happens here. I do 34 sine 114 divided by 12, and I get this answer, 2.59. Remember what we said? All the sine values have to be between what? Right. And watch when I do this. Second sine of that answer, nope, can't do it. It gives you all this stuff about how it can't be done, blah, blah, blah. All right, so we would now say there's no solution to this. Okay? So on this, only when we're finding angles, we might have one solution, we might have two solutions, or we might have no solutions. If you notice this as soon as you draw the picture, go ahead and put no solution. You may or may not notice it. If you don't notice it, you will once you try to do it. Okay? All right, any questions on that? Pretty easy formula. Tomorrow we'll go into the law of cosines, which is a little bit tougher to use. All right.